Okay, so for this one, you need to find the magnitude of the sum of these two vectors. So we need to remember, how do we write a vector? We write a vector in the form x comma y, where xy represents the coordinate when we've taken the initial point and moved it to 0, 0, and then the terminal point is the coordinates xy. The way that we find this is it's always the terminal minus the initial. If you do terminal minus initial, you're going to get x comma y. So for AB, A is the initial point, B is the terminal point. So our vector AB is just going to be A is initial, B is terminal. So it's going to be -4 minus 2, 7 minus 1, which equals -6 comma 6. And then CD, or DC, D is the initial, C is the terminal because of where the arrow is. So we're taking D away from C, so it's going to be 7 minus 4 and 2 minus a -7, which turns out to be 3, 9. The next part is our favorite part of vectors, which is whenever you want to add vectors together, if you know your coordinates, all you have to do is add the coordinates up. So -6 plus 3 is -3. 6 plus 9 is 15. So the coordinates of the vector AB plus DC, which is what we refer to as a resultant vector, are -3 comma 15. So then we go through and find what that looks like. So it looks like this. We need to find the angle theta, and we need to find the length. Well, the length is very easy to do because the length is just going to be Pythagorean theorem. So the magnitude just equals the square root of 3 squared plus 15 squared, which equals the square root of 224, because 9 plus 2, or 234, sorry. 9 plus 225. That is divisible by 9. So 9 goes into 234 26 times, and so you get 3 root 26. If it doesn't tell you to round, then leave it in radical form. If it told you to round, then you just find out what the square root of 234 is. All right, then to find theta, we always use tangent if we know the coordinates, and it always turns out that it's just going to be the tangent of theta equals the y over the x, but it's the absolute value of it. We always want the positive. So that means we want to take the inverse tangent of 5, and that turns out to give you 78.69 degrees, and that is north above the x-axis of west, and so north of west.